Net present value is the next project selection method for review. It calculates an accurate value for the project in today's dollars. If the net present value is greater than zero, accept the project. If it's less than zero, the project should be rejected. Positive value of net present value means the project will earn a return of at least equal to or greater than the cost of capital. Projects with high returns early in the project are better than projects with lower returns early in the project. In our example here, we're once again comparing Project A to Project B. Using the calculation that we just learned for discounted cash flows, we're calculating the present value for each year of projected revenues. You can realize immediately that this is more precise than figuring the lump sum totals that we just did in our previous examples. For both Project A and B, you can see the revenue forecasts for 3 years. Using a 12% cost of capital, the present value is calculated for each of the 3 years. You can see that Project A has a grand total of $24,446, and Project B's total is $23,732. The initial investment for doing each project is $24,000, which is subtracted from the total. Project A has a positive number, however Project B does not. Thus, Project A would be accepted and Project B would be rejected. Lastly, we have the internal rate of return. This is the discount rate when the present value of the cash inflows equals the original investment. This can be done manually, but financial calculators or computers can handle the calculations much more easily. The higher the internal rate of return, the better, and it assumes that cash inflows are reinvested at the internal rate of return value. So what does this mean to you? For the exam, you only need to remember the following. The internal rate of return is the discount rate when the net present value equals zero. The internal rate of return assumes that cash inflows are reinvested at the internal rate of return value. Choose the projects with the highest internal rate of return. This concludes the benefit measure models for project selection methods. There's only one other method to review briefly, and that is the mathematical model or constrained optimization model. The mathematical models are usually used for very large, complex projects. It's very complicated, and for the purposes of the PMP exam, you only need to know that they use linear, dynamic, integer, and/or multi-objective programming in the form of algorithms to obtain the information that may be useful for the evaluation. This concludes the project selection methods. In the next section, we'll review the other tools and techniques for charter development.